Hi there, science fans! It's Caitlin, here to talk about something crucial for safety in many industries. Carbon dioxide detection, CO₂. It's essential for brewing beer, keeping food fresh, and even making fizzy drinks. But did you know that in high concentrations, CO₂ can become a silent hazard? Invisible and odorless, CO₂ can sneak up on you. Today we're talking about carbon dioxide detection, why it's so important, how it works, and where it's needed most. Let's dive in before things get too bubbly. Okay, let's start with the basics. What exactly is carbon dioxide? Well, picture this. Tiny little carbon atoms like the ones in this pencil, holding hands with not one but two oxygen atoms. That's CO₂. It's all around us, in the air we breathe out, in the bubbles of our favorite sodas, and even in the dry ice that makes that spooky fog at Halloween. While CO₂ is essential for life, plants need it for photosynthesis, too much of it can be dangerous. Our bodies need oxygen, and when there's too much CO₂ in the air, it displaces the oxygen, making it hard to breathe. Imagine being in a crowded room with poor ventilation. As we all exhale CO₂, the concentration builds up, and we might start feeling lightheaded or even dizzy. That's why understanding CO₂ and its potential dangers is so important, especially in industrial settings where it's often used in large quantities. CO₂ might seem like a simple gas, but it's a real workhorse in many industries. Take breweries, for example. Yeast needs CO₂ to work its magic and turn sugar into alcohol during fermentation. That's what gives beer its fizz. Then there's the food industry. CO₂ is used to keep food fresh during packaging. Ever wonder why those bags of salad stay crisp? It's often because they're flushed with CO₂, which slows down spoilage. And let's not forget about dry ice. It's simply frozen CO₂, and it's used to keep things cold during shipping. But here's the thing. While CO₂ is incredibly useful, it can also be dangerous if it leaks from these industrial processes. That's why CO₂ detection is so important in these workplaces. Without proper detection, CO₂ could build up to dangerous levels, putting workers at risk. Now, let's talk about how CO₂ affects our bodies. It's a topic that's often overlooked, but understanding it is crucial for our well-being. Our bodies are incredibly sensitive to changes in CO₂ levels. Even slight variations can trigger noticeable reactions. Even small increases can have noticeable effects. This is because CO₂ directly impacts our respiratory system and brain function. At lower concentrations, around 1,000 parts per million, ppm, you might start feeling a bit drowsy or get a slight headache. These symptoms are your body's early warning signs. As the concentration increases to 2,000 ppm, things get more serious. Your body starts to struggle more noticeably. You might experience dizziness, increased heart rate, and difficulty concentrating. These symptoms can severely impact your ability to work safely and effectively. Now imagine CO₂ levels reaching 5,000 ppm or higher. This is a critical threshold where immediate action is required. This is where things get really dangerous. The risk of severe health consequences becomes very high. You could experience confusion, rapid breathing, and even loss of consciousness. These are signs of acute CO₂ poisoning. Prolonged exposure to high levels of CO₂ can lead to more severe health problems, including organ damage and even death. It's a silent but deadly threat. That's why it's crucial to have reliable CO₂ detection systems in place, especially in industrial settings where leaks can occur. These systems are essential for early detection and prevention. Remember, CO₂ is odorless and colorless, so you can't rely on your senses to detect it. This makes it even more dangerous because you won't know it's there until it's too late. That's where CO₂ detectors come in. There are silent guardians, alerting us to danger before it's too late. Investing in these systems can save lives and ensure a safer working environment for everyone. How does CO₂ detection work? We know CO₂ is dangerous in high concentrations, but how do we detect something we can't even see or smell? CO₂ detectors are like tiny, high-tech noses that can sniff out even the smallest amounts of CO₂ in the air. One of the most common types is the non-dispersive infrared or NDIR sensor. Inside the sensor, there's an infrared light source, a sample chamber where the air goes, and a detector. When CO₂ molecules enter the chamber, they absorb some of the specific wavelengths of infrared light. The detector measures how much of that light is absorbed, and voila! It can tell us exactly how much CO₂ is present in the air. These sensors are incredibly sensitive and can detect even tiny changes in CO₂ concentrations, giving us early warnings of potential leaks or hazards. It's like having a tiny scientist on guard 24/7, keeping us safe from this silent threat. where CO₂ detection is critical. Now that we know how CO₂ detectors work, let's talk about where they're needed most. Breweries, with their fermentation tanks and CO₂ storage, need to be especially careful. A leak in a confined space like a walk-in cooler could quickly create a dangerous environment. Food processing plants, especially those using CO₂ for packaging or preservation, also need robust detection systems. Greenhouses are another place where CO₂ detection is crucial. Plants love CO₂, and it's often pumped into greenhouses to promote growth. However, too much CO₂ can be harmful to humans, so monitoring is essential. Cold storage facilities like those giant walk-in freezers you see at grocery stores often use CO₂ as a refrigerant. And let's not forget about places like restaurants and bars that use CO₂ for draft beer or soda fountains. Basically, anywhere CO₂ is used or stored in large quantities, you need reliable detection systems to ensure the safety of everyone nearby. Fixed versus portable CO₂ detectors. Today, we're diving into the world of CO₂ detection and exploring the differences between fixed and portable CO₂ detectors. Let's talk about the different types of CO₂ detectors. Understanding these differences can help you choose the right one for your specific needs. First up, we have fixed CO₂ detectors. These devices are designed to be permanently installed in a specific location. They're permanently installed in areas where CO₂ leaks are most likely to occur, like near fermentation tanks in breweries or CO₂ storage areas. This ensures continuous monitoring in high-risk zones. Think of fixed detectors like the smoke detectors in your home. Just as smoke detectors provide constant vigilance against fire hazards, fixed CO₂ detectors are always on the lookout for dangerous CO₂ levels. They're always on guard, constantly monitoring the air for any signs of danger. If CO₂ levels rise, they trigger alarms to alert you immediately. They're hardwired into the building's electrical system and often connected to alarms or ventilation systems to provide early warnings and automatic safety measures. This integration ensures a rapid response to any CO₂ threat. Next, we have portable CO₂ detectors. These are versatile and can be carried around easily. They're smaller, lightweight, and easy to carry around like a trusty sidekick. You can clip them to your belt or carry them in your hand. Portable detectors are great for spot-checking CO₂ levels in confined spaces before entering, like those walk-in coolers or fermentation tanks. This makes them ideal for on-the-go safety checks. They can also be used for personal protection, providing an early warning if CO₂ levels start to rise. This is crucial for workers who frequently move between different areas. For overall area monitoring and automated safety systems, fixed detectors are the way to go. They offer comprehensive coverage and are ideal for large, high-risk areas. But for personal protection and spot checking, portable detectors are essential. They provide flexibility and immediate feedback, ensuring safety wherever you go. Here's the thing about any scientific instrument. Even the most sophisticated CO₂ detector is only as good as its calibration and maintenance. Think of it like a car. You wouldn't drive your car for thousands of miles without ever changing the oil or checking the tire pressure, right? Well, CO₂ detectors need regular checkups too. Calibration ensures that your detector is accurately measuring CO₂ levels. Over time, sensors can drift out of calibration, which means they might not give you a true reading when it matters most. Calibration involves exposing the detector to a known concentration of CO₂ and adjusting its readings accordingly. Maintenance is equally important. Dust, dirt, and even insects can interfere with a detector's sensors, leading to inaccurate readings or false alarms. Regular cleaning, sensor checks, and replacement of worn-out parts are essential for keeping your detectors in tip-top shape. Remember, a well-maintained CO₂ detector is a reliable detector, and a reliable detector could save lives. So don't neglect those checkups. Automated safety features when CO₂ detectors take charge. Let's talk about the brainy side of CO₂ detection automated safety features. These systems are designed to be the first line of defense in environments where CO₂ is used or produced. They are not just passive devices. They actively monitor and respond to potential hazards. These are the technological marvels that can spring into action when a CO₂ leak is detected, often before humans even realize there's a problem. The speed and efficiency of these systems can make a significant difference in preventing accidents and ensuring safety. Imagine this. A CO₂ detector in a brewery senses a leak. The detector is constantly analyzing the air quality. And the moment it detects an abnormal level of CO₂, it springs into action. It immediately triggers an alarm, alerting everyone in the area to evacuate. This quick response is crucial in preventing exposure to harmful levels of CO₂, which can be dangerous or even fatal. But it doesn't stop there. The system is designed to take multiple actions simultaneously to ensure maximum safety. The detector can also be connected to the building's ventilation system, automatically activating fans to clear out the CO₂ and bring in fresh air. This helps to quickly reduce the concentration of CO₂ in the air, making the environment safer for everyone. In some systems, the detector can even shut down CO₂ flow from tanks or cylinders, preventing further leakage and minimizing the risk of harm. This is particularly important in large industrial settings where the volume of CO₂ can be substantial. These automated safety features are crucial for minimizing the impact of CO₂ leaks, especially in large facilities where evacuation might take time. The ability to quickly and effectively manage a CO₂ leak can save lives and prevent significant property damage. They provide an extra layer of protection, ensuring that even if humans are slow to react, the system is there to take charge. This redundancy is key in maintaining a safe working environment. So, when choosing CO₂ detection systems, be sure to consider the automated safety features they offer. These features can make all the difference in creating a safe and secure environment for everyone involved. The fun side of CO₂ detection, a necessary guardian. CO₂ detection might seem a bit serious, but trust me, there's a fun side to it too. Think of CO₂ detectors as the unsung heroes of the science world, like the sidekicks who always save the day. They're like the guardians of good air, ensuring that we can all breathe easy. And just like any good superhero, CO₂ detectors come in all shapes and sizes. There are small portable ones that fit in your pocket, and larger, more sophisticated ones that look like they belong on a spaceship. So the next time you see a CO₂ detector, give it a little nod of appreciation. It might not be as flashy as a superhero, but it's doing an important job, and it deserves our thanks. Staying safe with CO₂ detection. Knowledge is power. Well, there you have it, science fans. We've explored the ins and outs of CO₂ detection, from the basics of carbon dioxide to the importance of calibration and maintenance. Remember, CO₂ is a powerful gas that plays a vital role in many industries. But like any powerful force, it needs to be treated with respect and handled with care. CO₂ detection systems are our first line of defense against the dangers of CO₂ leaks. They provide early warnings, trigger safety measures, and give us time to react before it's too late. By understanding the risks associated with CO₂, recognizing the signs of CO₂ exposure, and knowing how to use CO₂ detection systems properly, we can all do our part to stay safe. Let's make sure everyone understands the risks and knows how to protect themselves. Stay safe, stay informed. Thanks for watching. I hope this gave you a clear understanding of why CO₂ detection is so important and how it works. Remember, CO₂ might be invisible, but its effects are very real. Don't forget to subscribe for more safety tips and insights. Stay safe, stay informed, and keep those CO₂ detectors active.